Hi everyone, welcome to this session on sustainability and built environment. We've got three presentations like other similar sessions. The first paper will be looking at scenarios of occupational capacity. The authors are from Egypt, University of Cairo, Egypt. The second paper and the third paper are on a similar theme on waste management. So the first paper look at wood waste, whilst the second paper look at causes of waste, how we can look at identify critical materials of waste. So I'm kind of hearing, okay, all right. Do we need to mute the rest, Apollo? I don't know. I keep hearing a bit.
No, just go to the video and play.
Okay, I'll keep hearing some noise. So we will start with the first paper by Ismaeel, Fayrouz, if I pronounced your name right, which looked at scenarios of occupational capacity of higher education buildings in times of COVID. All right.
No, that's not the one.
That's not the one, yeah. Okay.
Yeah, that's it. No, the first one.
This one?
No.
Still not seeing. No.
Shall I take over? Let me just try mine.
Yeah. Okay. Yeah, that's correct.
Hello, my name is Fayrouz Mohamed, and I will be presenting the paper with scenarios of occupational capacity for high educational buildings in the time of COVID. The paper was written by 3 authors. For more information, kindly check the links in the slide. First of all, the introduction. The first case of novel coronavirus was recorded at the end of 2019. The problem was appeared in April 2020 when 94% of students worldwide were affected by the pandemic COVID-19. The used keywords is COVID pandemic, high educational building, indoor air quality, ventilation, and whole system thinking. The pie chart showed the percentage of documents about COVID-19 in all fields, and engineering was the least field to publish about COVID. The total document at 2020 was 24 paper, and it increased to 50 paper by 2021. This highlighted that there was no defined parameters for universities at national scale from a holistic point of view that is divided into physical method, which include indoor air quality and furniture setting organization, and tactical method, which include occupation density. The hypothesis of paper is to make unified guideline for redesigning indoor spaces to enhance indoor air quality and reconsider furniture settings and managing occupation densities from a whole system thinking approach to see interrelations of these varying parameters. Second, methodology. The methodology map is the hierarchy of the research starting with the aim to provide design guidelines through these objectives with mixed approach method that is divided into qualitative method and quantitative method. The qualitative method through data collection for the 3 parameters of the research, and the quantitative method through design builder simulation for a design studio to get the risk scenarios. Then integrate them in whole system thinking approach by using Vensim software. Then the results to get a unified design guideline for universities for ventilation rate and occupation density and furniture settings in the time of COVID. The literature review is the data collection from journal articles and conference papers and book chapters by using Science Direct database with a range of years from 2011 to 2021. I found that they discuss the parameters separately, including indoor environmental quality, ventilation regulation during COVID-19, and precautionary measurements, and do not discuss the integration between these parameters in higher education buildings. The literature map is a brief map that shows the points discussed in literature review, including indoor air quality in education buildings and the impact of COVID in education buildings and the system dynamic approach. Then I came out with standards and regulations during COVID for ventilation rates and CO2 concentration in order to use them as an input data in simulation. The case study is a design studio in the British University in Egypt. The table shows the existing case data and the existing floor plan. The used software is Design Builder and the input used in the simulation is the layout and activity HVAC of the design studio. The output data is environmental data that is the airflow inside design studio with different occupation scenarios to get design guideline for design studios in Egypt in the time of COVID. This is the input data used in simulation for the base case and COVID scenarios. This table shows the results from simulation in the term of air change per hour and the formula of airflow used to get the airflow in terms of liter per second per person to be compared and integrated with the Egyptian code classification of indoor air quality level and CO2 concentration. After comparing the results and the Egyptian code, I found that 100% full occupation, the base case, is the lowest indoor air quality that have a high risk infection on occupants, while 25% occupation was the highest indoor air quality that has low infection rate inside design studios. After integrating Egyptian code and the results from Design Builder, I get the design guideline for design studios in the time of COVID with a layout for furniture settings organization that based on occupation densities inside design studios and the range of CO2 levels for each indoor air quality level classification. The results were converted in a cause and effect Venn diagram to show the main parameters of the guideline, occupation and ventilation rate and furniture settings and their effect on the indoor air quality. In the diagram in loop A, starting by indoor air quality, if it increases inside the space, the ventilation rate increases. By the time when ventilation increases, the indoor air quality increases. This loop is reinforced loop. And in loop B, starts with indoor air quality. If it increases inside the space, the occupation density increases. Hence, the indoor air quality decreases. This loop is balancing loop. And loop C, also a balancing loop. To conclude, the aim of the paper was achieved by providing guidelines through two-method approach, then by integrating the parameters, then the result which is the guideline for design studios in universities for ventilation rates and occupation densities and furniture settings. The table shows the recommended COVID scenarios with occupation 50%, which mean medium indoor air quality, and 75%, which mean moderate indoor air quality, with a range of air and CO2 levels that's stated in the Egyptian ventilation code, then the furniture layout for each scenario. Thank you for listening.
Thank you. Thank you for the presentation. Can we now have time for questions? If you have time for questions, if you have any questions. Hello?
Alex, it's me. I've promoted Norhan to presenter, so they are available to respond to any of the queries that might come.
All right. Okay, so if you've got any question for the presenter, you can either use the chat menu, or you can unmute yourself and ask the question. Or if you've got any comment, contribution, please.
There's a question from Marcus. Can I check that? Hello,
Norhan? My name is Fayrouz Mohamed, and I will be presenting the paper with a title, Scenarios of Occupation.
Right. So Norhan, you are around for the question. There is a question from Marcus, where they ask that how do you recommend using system dynamics in measuring air quality? Norhan, can you make sure that your microphone is turned on? Norhan, do we have you on? Let's see if we can. Let's see if we can turn. Oh, is that you, Norhan?
Yes, we're the authors. Yes, this is
okay. Oh, excellent. Yeah. Oh, it's very good. We have even both of you at the same time.
Yes.
So we're gonna have twice the answers. So there was a question from one of the delegates, where they are wondering as to how you can use
the science of system dynamics.
Yes, please.
Actually, the science of system dynamics has been very useful since now to solve many complex problems. And in this study, we have used it to analyze the consequence or the synergies and trade-offs between the ventilation rates, the furniture settings, and the occupation densities, which in time of COVID, because we as educational facilities, we have received like recommendations from the World Health to make the occupation densities around 50%, but this 50% is debatable, and that's how we showed in the study how it can be calculated based on the science of system dynamics, because it's like a trade-off or scenarios between the ventilation rates, the standards according to the codes, the furniture setting after studying or analyzing the functional requirements of each space, and based on the educational space requirements. And this determines the occupational densities based on that in time of COVID, of course, and using the precautions or paying attention to the precautionary distances and so on.
Okay. Thank you very much for that. I wonder whether Marcus has any sort of follow-up questions, or they are satisfied with what has been given to us as a response.
And also, Marcus, kindly note that the science of system dynamics is also deals with the change of parameters. So we may receive some changes or updates which happen occasionally after as a result of the COVID pandemic. So when you change the parameter in the model, you get the changes or the recommendations based on that. So this can be easily applied in educational facilities according to the type of space, and you can accordingly allocate or determine the occupation densities which should be allocated for each educational space based on that. Have I answered you properly, Marcus? Did I answer your question?
Yes, he says he sent a message to say thank you for your explanation. So thank you very much for that.
Thank you.
Right. Are there any other comments from anyone or questions from anyone?
Maybe just a quick one from me. Any reason why you chose that particular studio as opposed to any other building in the university?
The city and the space were chosen like a case study, but of course you can change the educational space and accordingly it will feed back into the furniture settings and the ventilation rates according to the code, the local building code. So it's like a pilot study, a small pilot study for this educational space in this city, but it can be replicated in other cities, in other educational spaces. Accordingly, it will give, or it will provide the recommendation of the occupational density, which should be considered during the COVID pandemic.
Okay, I think. Are there any other comments from anyone? No? Okay, over to you, Alex. I understand, if I can just have a quick check. There's somebody called Alan who's, I'm not sure whether that is a message for us. I think we can go to the next paper, Alex.
Okay. I think I lost connection at some point.
Oh, sorry about that. Anyway, Norhan, thank you very much, and your colleague. I think if you can hang around, there may be some comments that will come. People will think about as we go along. But thank you very much for that that paper, that presentation, and the explanation that you've given. Okay, thank you.
Thank you, Alex. Thank you, Bob.
All right, thank you. Okay, we look at the next paper, which looks into waste minimization practices in residential construction. So waste minimization practices.
Greetings from Auburn University. My name is Alan Bugg, and on behalf of the lead author, Marisol Cho, and my co-authors, Anoop, Sattineni, and Redden, thank you for allowing us to present our paper on wood waste minimization practices in residential construction. Currently, in the United States, there are about 570 million tons of construction waste that are generated every year. Of this amount, approximately 40 million tons consist of wood products. This research investigates methods currently practiced that minimize waste generation and maximize recycling wood waste in residential construction. So the reasons to reduce wood waste in construction, most of them are pretty obvious. Number one, it reduces the use of fresh forest biomass, which in turn helps reduce global warming. It reduces the need for additional landfill space. And wood waste also affects the profit margin of construction companies and ultimately the cost to owners. So based on the literature review, there are 35 main contributors or causes of construction waste. The three top contributors are inexperienced workers, design and construction errors, and the use of conventional design and construction methods. So the basics for reducing wood waste are the 3 R's: reuse. This primarily consists of salvaging wood from construction, reduction in waste at the source through design and through lean, through design, and then in construction through lean framing methods, And then lastly, the one we're most familiar with is recycling, where we take waste products, process them, and regenerate them into other products, so they can be used as other products. So the methodology, we conducted a total of 8 interviews, semi-structured interviews with construction professionals of all types and from all over the United States. The data was analyzed using computer-assisted software, which resulted in the figure that you see here. So for every question, we generated one of these figures. However, unfortunately, because of space limitations in the paper, we couldn't include them all. So I just include this as an example. So the first question was, based on your experience, which lumber category produces the most waste during construction and which the least? And so based on the answers that were given, after we put in the software, the types of lumber that produce the most waste were sheathing material, dimensional lumber and bracing material, and the least were studs and glue laminated beams. So, and this is just the methodology that we use for all the questions. So I'm going to run through the questions real quick. So how does labor cost impact your company's decision to minimize waste? 5 out of the 8 stated that labor costs had a negative impact. In other words, most of the wood waste minimization practices that are currently being used are not viewed as being cost effective. And surprisingly, only one respondent stated it was their company's policy to recycle on every project. So questions 3 and 4 kind of go hand in hand. So when providing a turnkey framing installation, as opposed to labor only, what type of wood minimization methods are practiced? And every respondent stated that when the framing contractor is also responsible for buying material, waste is better controlled, simply because the people who are installing material have an economic interest in minimizing waste. And you can see from the results to question 4, waste can be reduced from about 30% when the framer doesn't buy the material to around 10 to 12% when the framer is responsible for buying the material. Question 5, how to best minimize waste on construction. Can you describe how best to minimize waste of construction materials? And so the things that impacted the most are project design. In other words, by removing design errors, and also maximizing standard designs that have fewer odd dimensions. You can also, that's the primary way you can minimize waste. Also also time and schedule constraints so that people are given time to practice waste minimization. Also, labor versus material costs, and we'll talk about this in a little bit. Material costs for wood are really skyrocketed in the United States. So that factor alone, because prices have almost doubled, although they've come down a little bit, that is helping control wood waste because it's becoming economically unsustainable to waste wood. And then the 4th item was having skilled framing crews. In other words, training and also retaining skilled framing crews was seen as a primary factor in minimizing waste. So some of the practices, the question 6, some of the practices the company uses, they use scrap wood for blocking and bracing, also having materials delivered in bundles that correspond to the wall section being constructed. When asked if they were familiar with advanced framing or optimum value engineering framing techniques, only one respondent said that he'd ever used advanced framing. And that's a technique that's been around since the 70s. However, in the United States, people have been slow to adopt it because it requires a little bit of training. Likewise, question 8, do you use software to minimize waste, and only one respondent said they used AutoCAD. But that one respondent said it was great, but it was just, it cost money to produce AutoCAD drawings. But then at the end of the day, they saved waste and also increased the efficiency of their crews. And so when I ask if minimizing of lumber waste should be included in project metrics, the consensus of all the respondents was that wood waste is a good idea, but right now the costs associated with it are prohibitive. They viewed the concept as a virtue, but not a business practice. Here again, this survey or this data was collected right at the start of the pandemic before lumber prices increased dramatically. And so respondents might have a different view if asked the same question today. So in conclusion, there are three paths to choose from: reduce, reuse, or recycle wood. And it's just a question of finding the proper balance. As leaders in the construction industry, we've got to figure out how to make protecting the environment as economically viable as possible. So I'll be glad to answer any questions that you have. And thank you again for allowing us to present.
Thank you. I've just noticed that it seems none of the authors are online. Is that correct, Apollo, or is that I'm not seeing well? I've gone through the people online. I don't think is any of the authors for this paper online at the moment. Okay, it seems none of them are online. We can still use a few minutes to discuss the paper in the absence, take up any feedback or comment, and maybe document them and send it to the authors. So if you've got any observation, we can use maybe 5 minutes for, keep the forum active and have a bit of discussion. Any observation from the methodology, the key issues from the research? Is there any similar, should I say, situation in other countries with wood waste being the main causes of waste as compared? I think in states they built using wood in residential buildings a lot. So that could be a factor. Is there similar experiences in other countries people could share with us? Questions, observations in the absence of the authors?
Alex.
Yeah.
I understand there is somebody who's the technical team trying to get into the system, called Alan, who is one of the authors. Okay. So I don't know, it might be prudent of us to give them a bit of time to see if they can get in okay. for any comments. But we encourage delegates to, if you have any comments, queries, please post them on the chat. And when Alan comes, then we can get him involved in trying to address the comments.
Thank you, Apollo. Yeah, but like Apollo said, whilst you are waiting, if you've got any comment, observation from the paper, we can start talking about it whilst we wait for the author. Anybody?
No, I can't see anything on the chat.
Mm-hmm. The same.
And
I think I made one observation. I don't know whether just me or other people saw the same thing. In the methodology, the author did mention the use of interviews in the abstract and also during the presentation that they interviewed 8 people. But in the actual paper on the methodology session, they did mention the use of mixed method and the relying of data from government. But I don't seem to notice any quantitative data analysis in the paper. Is that a similar observation from other people?
Okay. No. Alex, I suggest we go to the next paper because we go to the presenters.
All right, you're right. Okay. So if there's no question, comment, you move on to the next paper then.
Yeah.
Everyone, myself Prashanth Kumar, presenting a framework for understanding interrelations between material waste causes using DEMATEL and SNA, which is proposed as part of ongoing research work at Indian Institute of Technology, Bombay, India, along with Dr. Albert Thomas. The presentation would begin with need for study, literature review on material waste causes, including the research gap, methodology describing the proposed framework, followed by analysis of data, summary, and conclusions. Every country, a signatory to Sustainable Development Goals, is identifying ways to contribute to sustainability. Construction industry is an important contributor to economic growth of a nation. Apart from that, it can contribute to sustainability by way of responsible production and consumption. It can take efforts to reduce material waste. Why material waste reduction? It is required because around 8 to 10% of the purchased materials is resulting into waste after the construction process, and also has cost implications on the project, affecting project performance, as around 40 to 60% of the project cost has material component. Therefore, reducing waste improves environmental and economic performance towards sustainable construction. So, in order to reduce material waste, we need to first understand the reasons for material waste causes during construction projects. And the literature review has indicated numerous causes, and these are identified and grouped under 11 categories as shown here. While there are many studies which have used interviews, questionnaire surveys to rank all these causes, the research on understanding interrelations between these causes is limited. Therefore, this present study tries to understand the interrelations between the causes. Interrelation means that each category may lead to other category of causes, leading to material waste at site. In order to identify and quantify the interrelations of the material waste causes, a framework is proposed as part of this study, which is presented here. 11 categories of the waste causes. In order to understand their interrelation, do form as a 11 by 11 interrelations matrix, leading to 121 possible interrelations. And by excluding 11 self-connections, a total of 110 relations are available for quantifying their impact. Opinions of the construction professionals who are site supervisors and site managers have been taken on a 5-point Likert scale for every possible interrelation. The data collected is analyzed firstly using decision-making trial and evaluation laboratory, DEMATEL in short, and it was used because it will be helpful in identifying critical interrelations from the total possible relations, and also can categorize these 11 groups into a cause and effect map so that project managers at site can prioritize which one to be controlled. Further, the critical interrelations from DEMATEL are taken as input to social network analysis so that the Professionals' views can be visualized in a network, and the strength of each relation and each cause is analyzed with reference to the whole network. Therefore, the data collected is analyzed using a combination of network analysis methods, that is DEMATEL and SNA, which is the proposed framework of this study. From the data collection, the 110 interrelations are taken, and a direct relation matrix, which is presented here, is derived. By performing DEMATEL analysis, which means converting the direct relation matrix to the normal relation matrix, and with the help of identity matrix, a total relation matrix is derived, which has helped in producing the cause and effect network, which is shown here. As we can see here, design, tendering, lack of policy, and lack of incentives and human related errors are the causes leading to the other group of causes as effects. 55 out of 110 relations were identified as critical and taken up for social network analysis. The network graph here represents those 55 critical relations, and the table here presents the key network characteristics of this 55 critical relations network. It can be inferred from table that human related, material planning, material procurement are more central to the whole network, requiring utmost importance to be given at site level to reduce material waste. To summarize, the study is conducted to understand the interrelations in material waste causes and proposed a combination of DEMATEL and SNA as network analysis method. From the DEMATEL analysis, 55 interrelations out of 110 were identified as critical, and of the 11 categories, 5 are identified as the critical causes, which are design, tendering, lack of regulation and policy implementation, lack of contractual incentives, and human-related errors. Further analysis of these 55 important interrelations using SNA resulted in 3 central causes: human-related errors, material procurement errors, and material requirement and planning errors. As human-related errors are identified to be more critical and central to the material waste generation at site, further studies can be conducted in this direction. While the study is based on opinions, the contribution lies in proposing a novel framework which uses 2 network analysis methods. We would like to thank survey participants who have spent their valuable time in providing the responses, the anonymous reviewers who have helped us refining the research paper, and ARCOM 2021 Managing Committee for providing this opportunity to present in the conference. Thank you.
Thanks very much, Prashanth. Thank you. Time for questions, comments, and contribution.
Yeah, thank you.
Okay, can I start from where you ended? By thanking the survey respondents. That was very good, because you said that the survey consisted of 110 questions. 110 questions.
Yes.
On the average, how long did it take to complete each survey of 110 questions?
Yeah, I have got around, they have taken around 20 minutes to complete, average. Some people have taken more time, and that's how, if you see, the response rate was less. I have sent to 114 respondents, but I have received hardly 34 responses. And but what I can tell is those 34 responses were from the respondents who are in fact working in construction sites, and they are into this site level execution process where they have seen the way of working. So taking that experience into the survey point is what I have taken and done the analysis further.
Okay, thank you. I was just a bit worried that completing 110 survey questions would have been very time demanding.
It took more time, and also I have given them two options. One is online option, and other option is I have given them an Excel sheet where I have put this kind of a drop down options which they can take it and fill them back and give it back to me through mail. Like that I have tried. I tried both methods there. As you know,
Okay,
construction response rate is somewhat less here. Okay, thank you.
Thank you, Farhan. Any other comment from the audience? Contributions, questions?
Can you hear me?
Yes, sir.
Yes, sir.
Okay. You just follow up on that question about giving them different options.
Yeah.
I wonder whether the different options had an impact in terms of response rate. Do you get more from one option than the other? And also, if you had those two data sets, are you able to distinguish in your data? I don't know. So the data analysis system you used, are you able to distinguish between those that came via the online system, for example, and others that came via the alternatives?
Sir, in both methods, what I have given them is these 121 questions, 110 questions, and I gave them the option of this Likert scale 5 point. So whether I used the Excel where I have given this as a matrix with every cell. So in Excel, it used to like only one single page, but there also they were doing 110 answers there. And in online, like some people will be more comfortable in online, so they could do it online. Whereas some people who are like say 15 years or something like that, they find it a bit discomfort in doing online. So I had to give them this one page sheet from where they can use the drop down buttons and fill it. But otherwise the responses taken is same from both instances.
Yeah, I understand that, but sometimes the method can affect the response. Yeah. This.
I understand, sir. Yes.
This thing from
it happens that too with so many questions. It may so happen that people tend to prefer only one method. So in this case, what has happened is I have received 34 responses, of which, if you see, online I have received around I think 25 or so. Balance 9 I received only Excel. So what I wanted to say was like those 9 people, they were finding it difficult to fill it online. So I had to like tell them, okay, you have other options, so that I get more responses from the people who are actually at site. So I was trying to improve my response rate there. So in that process, I have used this Excel as a alternate method.
Right. Okay. If I can follow up on that, so you got 34 responses.
Yeah.
And from those 34 responses, you've developed a model. Is that correct?
I won't say I have developed a kind of model, but I tried to take that response and done a quantitative way of analyzing it. If you remember, like in my entire study, the main contribution is to analyze it quantitatively to more of in a understanding interrelation. So that is where I try to use DEMATEL. Then from DEMATEL, I got 50 relations, which is also too huge. So for a project manager to focus on all these 50 relations would be really, again, it will be more time consuming. So I thought, okay, let me look at social network analysis, which will give us a graphical view of how these relations are there. So I have tried to adapt a combination of two quantitative methods, which is the major kind of contribution, I would say, from this study. However, like you said, we can go for other methods like structural equation modeling with number of responses is more like 200 and all. we can go for such things and try to do in the given time and in the given context. And further, my research area is this, and in this I am trying to move forward to get into simulation oriented explanations to wastages. That's what I'm planning for.
Yeah, but I suppose what I'm alluding to is with quantitative analysis, you want to have most techniques of quantitative analysis rely on robust numbers, robust figures, robust statistics from a relatively large data set.
Yeah.
So you've got 34 cases, really, and you are building relationships from 34 cases in your data set. I suppose what I'm querying is how reliable are these relationships that you found that are based on what some might argue is a small data set.
Yeah. So here, if you see, it is the sampling method that I have used was not statistical based. It is a purposive sampling with intent of knowing more information from site oriented people. So if you see in the methodology, I have tried to convey that in the paper where I mentioned that we have tried to target those participants who are from site. So in that way, that's why, like, had it been like statistical rigor, then I should have presented a statistical significance results as well, which I have the paper has that limitation, which I have covered in the limitation also, saying that it can be taken up further into a more studies. That's
okay. There is in particular quantitative studies, even qualitative studies. There are two concepts. There's something called internal validity, and then there's something called external validity. It seems to me that what you are suggesting there is that these relationships you found might well have some internal validity on the basis of the 34 responses you've got. Actually, beyond that, it's difficult to suggest that we can say that these relationships we found in the 34 cases can be expanded to maybe by a bigger population. Is that correct?
Oh, no, I'm not saying that it has to be like, I'm not generalizing it to everywhere. I'm just confining. I have put that that it is confined to the given study done in India. Like that I have put.
Yeah. Okay. We still have Norhan. Norhan, I have a query for you. I think they're mute. Let me just see if I can make them. Yeah, Norhan, are you still there? Norhan?
Norhan.
Can you hear me? We can hear you, Norhan. Oh, she's gone now. Norhan, can you hear us? Yeah, okay. I had a query for you in terms of your work, and forgive me if I didn't pick up what you may have said about this. I was wondering what, in your view, the practical implications of your work. Is there something that people in the industry can pick tomorrow or maybe in 6 months' time and use to improve, if you like, their practices?
Okay, a practical application in future, it can be used to develop something like a model, a computer model, in which educational facilities can use to determine the occupation density for each space, depending on the functional requirements. It is a drawing hall, a lecture hall, classroom, staff room, and so on, based on the circumstances or the latest development for the World Health Organization. So this can be, yes, one of the practical application of the study.
Okay, that's good. I was what? So keep going.
For management. also to manage, to draw management plans for each educational facility on, like for instance, the number of entries, student entries for their income, and so on. So yes, it has many future potentials to be applied in practice.
Okay, that's good. Alex, I was wondering whether Alan has managed to join us.
I can't see him online or in the group, not yet, unless I'm seeing wrongly. No, he hasn't joined.
Yeah. Okay. So we haven't had any luck there. Yeah. I also don't see any other comments from the chat.
No, the chat has been quiet.
Yeah.
Okay.
Yeah.
Can I ask Norhan a quick question?
Yeah, sure.
In terms of what is new from this study, because the results were showing that the best option is having a less capacity of 25%, which is kind of a known fact that in COVID or any such situation, all the protocol says that you reduce the number. So that seems to be an obvious answer, if I'm right. Anything new apart from that?
No, actually, the new about this is how to put it in a science, a systemic science, how to deal with this matter based on a scientific point of view. And also, we presented a number of scenarios pointing out the possibilities, the risks of having or applying this scenario. So maybe a facility cannot really go or opt with the option of adopting a 25% occupational density, so it will opt for 50% occupational density, but knowing that the ventilation rates should be increased above the recommendation of the local building code of X%, and so on. So we presented a number of scenarios, and of course this is this comes as just to show the variations. But if it is put into a systemic model, you can actually, you don't have to use the presented scenarios. So you may go for a 35%, and see how the recommendations will come up to you. So this is what's new about it. Presenting scenarios, yes, and thinking of it based on a scientific background.
All right, thanks for the explanation. I think that's clear.
Can I follow up a little bit?
Sure.
Yeah, we've got the two of you, so we'll save the time from Alan's presentation to get a chance to ask you more questions. The issue of occupancy, building occupancy, as we have understood the science of and the transmission characteristics of the virus, we have realized more and more critically the importance of ventilation.
Yes.
So, and again, I apologize if I didn't pick that up, but I was wondering how ventilation plays a part in your consideration of these scenarios.
Yes, of course. There's the two types of ventilation, of course, natural ventilation and mechanical ventilation, and each one of them has, or of course it depends on the context, contextual conditions, whether you're going to rely basically on natural, mechanical, or a mixed mode ventilation system. Depends, of course, on the local climatic conditions. For each type, there is a set of recommendation according to the local building code. So depending on the context where your building is, you're going to determine the type of ventilation system, and accordingly you have the recommendation of the local building code for the specific ventilation rates per hour. So we have covered this. Maybe not in the conference paper, but maybe in Fayrouz's. We are working on a journal paper developed after that, so this is also covered the variations or difference between opting adopting the different ventilation systems and how it will affect the results of the.
That's interesting because in the building where my office is, we've got lecture spaces, lecture theaters, seminar rooms, and so on and so forth. Our biggest, well, under normal circumstances, our biggest lecture theater is in the same building, which normally houses about 250 students, has been assessed to accommodate 19 students because of ventilation issues. Whereas another smaller room, which normally accommodates about 65 students, has been assessed to accommodate 39 students. Okay, so you've got large space. These are two buildings, so two rooms in the same building, so same sort of orientation. If you look at, if you like, those other characteristics that you might take into account at the global level in terms of design, they are all constant. But because of other micro issues that affect the ventilation of these spaces, a room that would normally take 4 times the number of students now takes half the number of students. So I think this issue is quite crucial, and I look forward to your further development of these ideas in the paper you referred to.
Actually, further study regarding this point is to link it with the energy consumption, because the more ventilation rates you opt for, the greater, of course, if you are relying on mechanical system, the more energy consumption you will have.
Yeah.
Energy consumption has to be considered as well.
Yeah, but I think there is quite a number of micro issues, because I said the case of these two rooms I've talked about, they are in the same building. So they're all subject to the same type of ventilation at, if you like, global level. But because of the different other dimensions, such as the volume of the building, of course, the circulation, the entrance where the entrance is located, and all sorts of things. As I said, a room that would normally take 4 times the number of students is now taking half the number. So it's fascinating stuff that. We will keep a watch on. Okay.
Thank you.
All right, Alex, are you going to wrap up now?
Okay, just a quick one is that the second paper, who were not around, have put in their email that if you want to get in touch with any question or comment, their emails in the chat box. I've put their email in the chat box. I think that they're just trying to get the name again. I don't think it's Alan, Robert or Alan, whatever it is. So
yeah, I think it is Robert, also called Alan.
Okay, so you can send any question or comment to that email I'll put in the chat box. Thanks very much, everyone. I think, although we didn't get all the 3 papers, but we made use of the time, and we had a very interactive questions for the 2 of you, which were too much on you. Thanks very much. With the 3 papers, I think it was clear that there was a common theme. 2 of them were concentrating on waste minimization, whilst the first one was on air quality in relationship to the COVID situation. Thanks very much. I hope you will pick up a few things. We can continue the conversation from here. So thank you.
Okay. Thank you, Alex. Thank you, Prashanth, and Norhan. I didn't get the name of your 2 other presenters, but thank you all.
Thank you.
Thank you. Thank you very much.
Yeah, cheers. Bye-bye.
Thank you. So, Apollo, how do we...
I'll do that in a moment. Before the delegates leave, I hope you've, of course, got your own timetable, but make sure you don't miss the Langford event. I am told it's going to be amazing. So if you have time, just take maybe 15 minutes for a cup of tea or coffee and we'll see you at the Langford event.
Okay.
Okay.
Okay. Thank
Yeah.
you.
Cheers. Yeah. Bye bye now.
Thank you. Nice meeting you virtually.